It's in the chat log. Onyx Books Note Air, 10.3-inch version. And don't buy this thinking that you're going to play video. It can. I haven't even tried it. I think it can do video at like 3 or 4 frames per second. And if you plug in a mouse, it's like using an ancient MS-DOS laptop. But other than fast updates, anything else you'd want to do, a text terminal works fine, web browser works fine. It's a great system.
Sounds good, Brendan.
Mm-hmm. Joshua, you can install a Linux desktop in, I forget the name of the program I found in the, I think it's in the Google Play Store. There's a package you can install that gives you lots of Linux user space stuff, and it even goes so far as to give you an X server, and on the X server you can run Mate or GNOME 3 or whatever you like. It would be really janky probably, but this machine has a fast CPU, so if you want to try something like that, find a similar machine before you buy this one. Borrow it and try it. And as far as peripherals, it has one USB-C port that can be OTG, which means that it can be a host or a client USB, a master or slave, or whatever the term is. And I plugged in a hub. I was able to plug in my trackball and a keyboard, and everything worked fine, except for that the mouse cursor was it looked kind of trippy. Oh, reading is perfect. I bought it for reading, but also with the idea that because it's so big, I wanted to be able to use it for other things. That's why I'm talking about all the Android and stuff. But if you want to read unencrypted stuff, install Code Reader, works perfectly. And if you want to read encrypted stuff, you need to install the app from whatever the vendor was.
Good.
Joshua asks, does the tablet have voice recognition? It might. It's whatever comes with AOSP is on this. The vendor added their own stuff to it. Don't know about voice recognition. Have to look it up. Oh, and this tablet, the Books tablet, comes with a really nice notepad program if you're okay with storing all of your notes on a server in China, which, because of that, I didn't even try it out. It works. It comes with a stylus, which the system sees as a separate input from your finger. So the default ebook reader that's built into it will actually let you mark up a book with a stylus while you use your finger to change pages. But I'm tired of talking about it. Somebody bring up something else.
Okay. I don't know anything about the Pine phone. On the native FOSS, Albus was doing some work on Pine, but I don't know if he just got the laptop or if he got the phone. But you might want to check out the Natick Foss. They have a similar meeting to this. And I can post the Jitsi ID for that meeting if you'd like. They meet the first Thursday of every month. And let me go ahead and post it.
Does Pine phone have anything to do with the Pine single board computer, the ARM64 based dev board? I'll have to look that up. Phone with a Pine in it.
I figured it was a phone made out of wood, just like in the when Matt Smith retired from Doctor Who in the last episode, there was a Cyberman made out of wood.
Yep, Pine 64. So we'll have to figure out how to share slides here, Jerry. I haven't done this before. Do I just do share screen and then select the LibreOffice, or?
Yes, if you're running X, that should work fine. If you're running Wayland, you may have to bring it up as a tab.
Okay, let me give it a shot.
Okay.
I have a splash screen, so.
Yeah.
Let's see.
Oh, there it is.
Nice. That's interesting. It didn't switch back. Try that again.
My understanding is that in the Zoom meeting that you can't, only the person who is the sort of started the meeting can do this, can share a screen.
That's not true. Anybody can share a screen.
Oh, in Zoom? Oh, okay.
And not in Zoom.
Oh, yeah, no, I'm talking about Zoom.
In Jitsi.
Yeah. No, I'm saying this is Jitsi is different from Zoom in that sense.
Yeah, that's correct.
Apparently.
So hopefully I won't crash tonight. I have one laptop for my slides and one laptop for my video and audio. So that way, if I do have one, I don't think my problem is with the laptops. I think my problem is with the fact that I'm sharing one Comcast J box with 64 apartments.
Okay.
And so what I've done is I've split the signals across the various Wi-Fi options I have. I also have an Ethernet 2 router option. It's just that my wife insisted that we put a VPN on it so that we can watch stuff from the BBC. So I'm not really sure that's going to be helpful to getting bandwidth. I think it'll be probably detractive, but we'll see.
Okay, that's fine. The other thing I do is on your slide machine, what I usually do is to go to settings, and in the settings panel, click on more, and then there is everyone follows me. It's under moderator, and you click on that, but you have to restart the screen share for that setting to be enabled.
Okay. Which is fine.
Yeah,
I can do
the
that.
reason that's important is because if you're showing some slides, you want the slide to show up directly on the live screen, the live streaming,
All right.
and not in tile mode.
So what were those settings again?
Okay, if you go to the three dots, the settings in the bottom where it said more actions,
Yep.
click on that and then go to settings. That's 1, 2, 3, the fifth one up. And settings on the top, it says devices, profile, calendar, and more.
Hold on. Yep.
Click on more,
Yep.
and then you go down under moderator settings. With everyone starts muted, everyone starts hidden, everyone follows me, do the everyone follows me. And then you
Okay.
have to restart the screen share.
Okay. So moderator, everyone follows me. Restart the screen share. Sounds good.
Yeah, it works most of the time. Couple of people it doesn't work for. But it's worked most of the time we've done that.
All right. Let me do that.
You're in tile mode. You have to do it on the machine that's doing the share.
Okay.
Was working perfectly a few minutes ago.
I know.
Yeah. Jabber pressed one of his magic buttons.
Okay. Well, I do this, and then I do this. And I go into slideshow mode. It's interesting that it doesn't go into slideshow mode on that one. All right. Well,
Yeah.
let me.
Yeah, sometimes what you have to do is to stop the share,
Yeah.
which you did, and then try to bring it up again.
Okay.
Might also be good to unmute it, because sometimes whoever is talking comes up. Yeah, it was working perfectly when Brendan was showing his Android tablet.
Yeah, that was me with my camera and mic on. I was not sharing a screen
Yeah.
for whatever that's worth.
Mm-hmm.
So does this room have an owner that can impose law on the rest of them? And can you just say this is the one to feature?
No, that's not.
No, it does not. Sometimes I wish it would. It would be a lot easier for things like that.
Free Software Foundation has their own private, well, semi-private Jitsi instance. And on there, they said that if you become a member there, you can own rooms on the FSF Jitsi.
Okay.
Which I take that to mean that if we installed it anywhere else on a server of our own, then we'd have the same thing, being able to own a room.
We don't. I don't want to host it on the BLU server because of our bandwidth. our provider's not going to like that. And considering what we pay them, we like to be really nice to them.
Okay, well, I can't do anything to make it go to the
Yep.
foreground.
Okay. I don't know. It's one of these stupid things that it sometimes works and sometimes doesn't.
Well, I could kill off my other. Yeah, okay. I could kill off my talking head.
Yeah.
You want me to do that?
Why don't you do
that's,
that and see what happens?
Yeah, that's right.
And why don't you mute everybody else? On your Kurt Slides machine.
Oh, do I have the capability of doing that?
Yes. The same.
Now, if you do that in a slides machine, they can be muting yourself as well.
No, I've got a separate machine for my talking head, so that would actually be good.
So your voice is going out on that machine, not on the one that your face is on?
Yeah, all I've got on my slide machine, I've got no microphone and I've got audio off on the slide machine.
Oh, okay.
That feedback you had was when I turned it back on.
Okay. Yeah, you'd have to turn off. You'd have to mute yourself and your talking head machine first.
Yeah, okay, I could do that, but if you want me to just kill off my talking head and then I'll do everything from my slide machine. I just don't have a camera on my slide machine, or I would do everything there.
Oh, that's fine. We don't need to see you.
Okay, I shall do that then. I don't think that's going to solve our problem, but I'll do it.
Yeah, I'm just experimenting right now. Okay. Looks like you have just one thing. We're still in tile mode, or as it Ricker likes to call it, Brady Bunch mode. Looks good. No, it's still Brady Bunch mode on the live streaming, but
I
it
just
came up full screen on mine. So let me give it.
No, I just tested with my coffee. It took 30 seconds before the video went to YouTube.
Yeah, it's working. So you got it.
Kurt, you need to unmute yourself.
Kurt knows. Yeah, he's working on it. Well,
It looks like you disconnected.
yeah, he's still muted on his Kurt slides, and he disconnected his talking head machine. Yeah, he just said, hold on, he may need to log back on.
The next big thing is we've got to add chapters to the YouTube recordings.
Okay.
I hang around in the No Agenda Network, which is a lot of podcasts and a lot of people sharing stuff. And we've got a Mastodon server. And there's this one guy that does not have a podcast, and he's always bitching that other podcasts don't have chapters.
Okay.
We heard something.
Okay, I
Yeah,
think I
Kurt-
have audio back. I don't know if I have video back, but
Yeah, you got audio back, but
All right.
you logged off Kurt slides.
yeah. Okay, so let me see if I can share. Uh, hold on.
Hey, Kurt, your video is still not being shared. I think you need to turn that on first.
Yeah, that ain't gonna happen. Shoot low. Oh, you mean it won't share? I can't share slides without video?
That's my guess. I've never actually tested that, but it makes sense.
All right. Well, then let's.
You can share without video.
Earlier, Kurt was sharing a screen and did not have a camera on that machine.
Mm-hmm.
So it'll work.
You may not have had a camera, but I'm guessing that the software was still enabled to share video, which is what was sharing the desktop.
So now we got a camera.
I got a camera, but I should be sharing something here. Hold on. Good Lord. Good thing we only have-
Sometimes there's a learning curve on this because Dick Miller always messes it up every month. He always gets it into infinite mirror mode.
There we go.
There we go.
All right. Well, let's see if I can get you into projection mode here. Is that still going?
Okay.
We're seeing the slide edit view.
I've got the slide up on the live streaming.
All right.
It's visible on YouTube now.
Okay. Well, we can start then if you want.
Yep, go ahead.
All right, folks. Well, I'm not going to spend a whole lot of time, the time I allowed myself remaining here, to talk about the single board computers and the dev boards that we've had come through the Boston Linux Users Group. But I did want to talk about, I'm glad Jabber called this the SBC retrospective over the decades, because I think one of our first introductions to the Texas Instruments animal boards were when Jay Golaguri came up here and showed us the Panda board in 2010. And you can't quite tell there, but that's a shot of the BLU meeting that we had in building E25 and I guess November 2010. So that link there, that bit.ly link, is something that he posted of his slides from the event. So that was our introduction to Panda board, but our first introduction to ARM processors was the Texas Instrument OMAP 3, and I won't talk too much about BeagleBoard because you'll have a BeagleBoard speaker here tonight, but I'll talk a little bit about the Gumsticks. Gumsticks also use the OMAP 3, the ARM Cortex A8, and that was the processor that was in the Megatux supercomputer project that came out of Sandia, and they demoed it at Supercomputing 10. It was a really remarkable demonstration of what you could do with a lot of ARM cores all daisy chained up either through the mini PCI connections that they had on the Stagecoach boards, or once you had 8 of them on a board, you could hook them up via Ethernet to a switch and then build. Those are 3 drawers of, I believe, 7 Stagecoach boards each. So they built up a very large ARM ARM v7 32-bit Linux cluster to do some botnet testing back then. They were using Open Embedded. I put when I got a couple of these drawers from Sandia, I put Ubuntu on the SD card. So you had an SD card per Gumsticks, and surprisingly, I was able to, as long as I got big enough micro SD cards, I could update that well into late Ubuntu years. I probably got it up to something from 2018, and then I couldn't find a way to support the OMAP 3 after that. Not on Gumsticks anyhow. Of course, my love was the OMAP 4, the Panda board. We with the help from BLU and MIT and Northeastern and BC and a couple of other schools, we built a solar powered supercomputer. So this was quite a few Panda boards built tightly together. We wanted to see how tightly we could build them and still keep it cool. We wanted to see if we could boot off a USB, and we could. Once power is applied to the Panda board, it starts. You can download a kernel from USB. You couldn't both power it and use USB for network. I tried a couple times to get something more powerful, like one of the nice white Samsung power dongles to power a Panda board, but it wouldn't keep it going. At least not with, because we put a bunch of things in there. We put a USB drive and a Wi-Fi card occasionally, so it wasn't going to power it that much. But I've got plenty of videos. At the end of this, when I pass it off to one of the other speakers, I can point you to a lot more of the devices we built. We had a lot of dev boards and a lot of single board computers, and we generally tried to build them into clusters to test out our BLAS, basic linear algebra, subroutine libraries, and the message passing interface libraries. My interest in them was definitely in what you could do with a dozen or so. using MPI and a small hub. I ended up getting most of the Panda boards, I think, in the States after I got these from Mozilla. Mozilla was getting rid of their build farm. They wanted, when Panda board was first available, they bought a ton of them. They were very hard to get in retail for a while because I think they bought most of the Panda boards through the distributors and used them as their ARM v7 build farm. So I inherited that. Texas Instruments eventually went to OMAP plus DSP, which they then distributed off into a lot of interesting projects. They had an OMAP 5 on the board for a while, but they ended up not pursuing that. I have a couple of slides on some of the products that came out of this division as well, the Hawking and the Shannon cores. That was an interesting combination. You could do a lot with that if you, and even GP DSP if you weren't using it just for traditional DSP. So we started doing ARM festivals and EHPC at MIT events here shortly after Texas Instruments came and started doing presentations at MIT. Like I say, we had a Panda board presentation in 2010. I think we had Jason and some Beagle board labs and workshops. 2011, 2012. We started inviting speakers up from ARM and ARM affiliates. This is back when ARM was spelled capital ARM, and they were mostly out of Cambridge, England, and not Austin, Texas. So we couldn't always get an ARM vendor, but we could get an OEM or an ODM. Hewlett Packard was packaging a Calceta ARM project into one of their Moonshot devices. We had one at 2013. I think Federico arranged for Sysadmin Magazine to sponsor breakfast, and then Canonical sponsored lunch for us, and then I think Federico had someone sponsor dinner as well. We got some interesting speakers from ARM back then. People from their division that were out there trying to find uses for ARM v8 or ARM v7 that would have been a predecessor to Internet of Things. And of course, Texas Instruments had a remarkable ecosystem. They had OMAPpedia and pandaboard.org and a really great way to just log on and ask a tech. They were very responsive. Their community support was great. Still is. I really miss the days of they had an animal board for every sort of usage case. If you needed DSP, they had something for that, and if you needed something with 4 Ethernets because you were using it as a router as well as a Wi-Fi device, they had a product for that. We had, speaking of SBCs, we introduced Parallella at one of the ARM festivals. I think a lot of us locally had Parallella. This looked really promising for embedded Linux, embedded HPC. And it was, he had built it upon the Z board, so he had 2 ARM hard cores in there, and you could do quite a bit with it right out of the box. And there was a lot of parallel development. It might come back. Andreas is back in Massachusetts. He's left his job as a DARPA PM, and he's back into the business of researching stocks and dev boards. We transitioned to IoT Festival.
Yeah, Kurt?
Yeah?
Yeah, a couple of people pointed out that your slides haven't advanced since the first slide. What everyone's saying.
All right. Is it on a different slide now?
Yeah, now it just jumped to slide 12. A moment ago it was on the first slide you did. Or I think number 2 was the one you started with. So we haven't seen 3 through 11.
All right. Well, why don't I won't go into presentation mode then. I'll just do it from this mode. Okay. Why don't I go back to the slide I was on? We can either fix this in post or I'll do it at the end after we get our speakers, because we're well into one of our speakers' time now. So I was going to talk a little bit about Plug Computer, but but actually what I have is a lot of show and tell of devices that are single board computers that are not ARM. We certainly experimented with Intel's brief foray into it was the Galileo and the Curie boards. Someone actually released a Debian distro for Galileo, and I tried that out. It was an interesting start. I don't know. So Genesee board, that was another ARM device. This board with the yellow tape on it, that was the Netgear WGT 634U, which was the duct tape of the Cambridge Public Internet, and a lot of really interesting ad hoc Wi-Fi projects. I truly believe that the IEEE wouldn't have taken ad hoc Wi-Fi seriously if it wasn't for all of these community efforts, especially with the WGT 634U. That you can see there's a slot there, a mini PCI slot. We could stick an Atheros radio in there if we didn't want the stock radio. It had USB on it. Oh, it's just a remarkable device. And we built a ton of these and hung them off of city-owned lampposts, and it was that was a really remarkable. You can get Debian etch on the WGT 634U from a guy. I'll post that. I'll post his URL at the end there. You're not going to get too much more than etch on there. There's a lot of reasons some of these dev boards didn't take off as people's main computer. There's no real-time clock, so every time you'd boot these things, you'd have to do some tricky thing with writing WTemp and doing that before you powered the machine down. And anyway, so I have a lot of these slides. This is a Cyrix GX Geode. I wanted to show this because that thing in the top right-hand corner is the Linux Disk-On module. So you could put Linux on there. It looked a lot like a Linux BIOS or Linux USB key that plugged right into the IDE slot. So you could put Linux on there, and you'd have an embedded, no moving parts, embedded Linux device. And we use this for we did support for the Hope Conference, which is kind of the East Coast equivalent of DEF CON. And we put a couple of wireless devices in there so that we could bridge. It was pretty cool. Considering that a lot of these things where you'd put them somewhere and you'd expect them to just die and not be able to reclaim them, especially the stuff we put on the City of Cambridge light poles. They generally would just die in place, either because they got wet because we didn't have NEMA 5 boxes, but generally the cost of them were so low that it was easier if you were going to roll a truck to reclaim old broken equipment. It was easier to just wait and stick a node up there to replace it, or to just not replace it. Just keep sticking new nodes in. So let me hand this. This is the Linux lunchbox from Sandia. Ron Minnick built a lot of these devices. This was Socris, I think. I have a couple of photos of things that I'm pretty sure were Socris boards. Like this is the Fawn, the fundamental array of wimpy nodes. We had another one, the Swan, the super wimpy array of nodes. But these were Socris boards, and I can't quite remember the model number, but I'll look that up. Like I say, it's already 7:30, so I'll hand this off. If Jason's here, I can hand this off to him, and he can talk about his latest efforts.
Okay, well, thank you, Kurt. So who's next here? Who's Jason? I see a Joshua and the Jonathan Finger. I don't see a Jason anywhere. Unless Jason's not connected. Oh, there's also a Jamie. Those are the only J's I see here. Jerry Feldman, of course.
All right. Well, let's see. If he's not here, we can either have Federico talk, or maybe if Josh, yeah, we can put Federico up if he's ready.
You all set there, Federico?
Unfortunately, I'm not. I'm trying to reboot another computer.
Boy, when we edit this down, this is going to be a 30-minute video.
I'm trying to show 3 bits of very new hardware to counterbalance the history that Kurt is giving you. But I need a working camera to do that, and I haven't managed that yet. I'll need another 10 minutes.
Hey, Josh Jelinski's online. Maybe he can tell us what. I know he doesn't have much to present, but he might have something to update us. Or is that a different Joshua?
Whoever it is not responding. So the camera's muted and the microphone's muted. You can't really tell if they're still there or not. They might have walked off to the bathroom. Might have grabbed a beer.
Hello?
Hello? Oh, there we go.
Hey. Yeah, I don't have much to show off, so I think the next presenter should just go. We tried to get the turtle board to work, the JX from JCore, and I've been thus far unsuccessful in compiling Linux for it and booting it up. It gives me a panic or dumps ELF every time I try to boot it up.
Okay, that sounds like something we can sort out. What's the processor on that board, Josh?
So that's a clone of a Super H re-implemented, or Super H2 re-implemented with some of the features that would have been in the Super H4 put together by the JCore group.
All right, yeah. And the actual processor on the turtle board is a FPGA?
Yeah, yep. So the actual processor is an FPGA, and it's written in VHDL.
Wow.
So yeah, it's a pretty neat project. I assume all the problems with it are completely on my end, to be fair. But at least on the host machine that I have, which is an Ubuntu 2004, I've thus been unsuccessful in cross-compiling for it. But I do have. I was able to build the Super H from their code, so that the bitstream compiles no problem to build the actual CPU.
Yeah. Okay, ELF executables might be something we could sort out, maybe with Gene Cooperman.
All right, neat.
Yeah,
I was pretty excited to use it. I know it doesn't run very fast to the speed of FPGAs. I think the presentation that group had given on that specific chip a couple of years back, they said that it was just approaching about the speed of the first versions of the Linux kernel.
yeah.
The speed of those CPUs at the time, just because of the slowness of FPGAs. But if it was actually produces a ASIC, it wouldn't be limited to those clock speeds.
So when they were saying they're going to do a 64-bit version, does that exist?
Presumably some of it exists. Their J32 seems to exist, but I haven't been able to use it yet. And they do have a J1 board where they backported it to a completely open board. So the turtle board the JX uses a what is it? I believe it's a Spartan 6. So you have to download like the web version of Vivado to compile the VHDL. But they are trying to use GHDL, I think that's the acronym, to do a completely open stack and program the ICE 40 FPGA series. But because they don't seem to make large enough LUT footprints for the open source lattice boards, they could only use kind of an SH1 or a Super H Type 1 size CPU. That's my understanding. Don't quote me on that. I hope you cut this out.
So, for the purposes of the viewers, I'm posting the listing of the presentation that the J-Core guys did. That Joshua and we ran a Boston architecture BARC event, and the J-Core folks presented the state of the art back in cripes. At this point, it's 8 months ago. So hopefully maybe they'll be able to speak at the next BARC.
Yeah, they were great. There's from people I've talked to, there's definitely some interest in using this. I know that when they started, the RISC-V stuff wasn't quite available yet. But I watched some of their presentations from other conferences where they were talking about code density and some other metrics, and there are definitely reasons, but beyond the fact that it's based on expired patents. So there's no at least according to their lawyers, no issues with that. So beyond that, the code density aspect of it, and there are some other metrics, make the Super H family a potentially an ideal candidate, depending on what your engineering requirements are. But it's definitely a choice CPU. But I don't have ELF stuff working yet. I see Kurt. Jerry. I've also been messing with the Pine phone. That's what I was asking about before. It doesn't have the IMU that I want, but it does expose a because it's a I think it's a 3-axis, and even if it was 6, I need a 9-axis to deal with yaw. But it does expose a I2C port, so it has power. So VCC, whatever, 2 lines, so a total of 6 pins are pogo pins are exposed on the back of it. And I've been working with putting together a board on KiCad to add a ATC, I think it's ATC 6088, or it's a name like that, ATCC 608, which is an encryption module. That's I2C, connects on I2C, as well as an IMU and some other stuff, so that we can use it for some of the gate and other research stuff that I collaborate with some people on. But what's nice about it is, since it has a full modem, the Verizon guys did say that they would accept it, so that you could temporarily switch it over with a SIM card and use that for uplink during an experiment, which was pretty cool. But we're not ready to use it yet. Still in development of the external case and board.
Cool.
Yeah. But when I have more stuff, I'll actually give a presentation. I just don't.
Oh yeah, no, that's cool. I knew you weren't quite ready today.
All right, gents. So let me see if I can do this without causing a feedback loop. Now we have actually 5 boards, not 3. Oh,
That's good.
well, I grabbed more stuff from the lab than I had planned. Let me see. Any news of where Mr. Kridner is?
No, I can't think that he would think that this was on Central Time, but maybe we'll see him in 20 minutes. I don't know. That's weird.
There's someone connect with the name Fellow Jitzer. You think that might be him?
So I'm going to switch from the phone. One thing that I wanted to work out is okay, let me see. Mute this guy. I'm going to hang up over here.
Did we just lose Federico?
If everything worked out, you can now hear me, maybe. No. Great.
Hey, before you start, Jerry Feldman's having some problems, and if he just connects to and relogs in, it might disconnect streaming. I'm not sure who was trying to talk while.
There's a problem with the microphone. Can you hear me?
I can.
Yeah, sure.
Okay, excellent. All right, great.
Federico, don't start yet.
Yeah, I'm going to try one more thing, which is I couldn't reverse the camera angle on the phone app. So, I'm sorry, on the phone web. So, VLU.org. I'm trying with the app because if we... Yes, okay, now we're going to have a... So, let me see. I'm going to screen share from here. All righty. So, the first device that I have here on the pile is something that Jason really should be talking about. And it's the newest BeagleBone, which is called BeagleBone AI. So it's at the top of my lab pile. So let's just take a quick look at what's in there. And then we'll just let Jason do the rest as maybe needed. Wow, there are too many Jitsies now. Let me kill this one. All right. So little live unboxing. And let's get the web page while I'm doing that. So the boards that I brought are literally the newest things, and one has arrived last Friday, so it's not fully populated yet even, but it's actually the coolest thing. For those of you that have seen me build clusters before. So while that loads here, all right, it's usual form factor for the box for BeagleBone projects, and usual type of content. So there is a quick start guide, which is actually unusual. There is actual documentation. The flip side is safety. On the front side, so legal disclaimers. On the front side, it's basically a bootstrap guide of how to connect to a PC, and a little breakdown, I don't know if you can see it, of what everything is on the board. Let's go into that in a second. The next thing is the board itself, and that's pretty much all that's in here. And it's so solid I cannot open it. There we go.
We're not seeing whenever you're showing us. You just see that DigiKey website.
No, there is a second Federico. There is a second Federico which has the camera of me unboxing. So you have to jump between the two people sharing.
And that's not appearing on YouTube.
Oh, I see what you mean. Okay, well, let me see if I can be a little bit more creative then. We'll try to switch. I don't know if it will work. Let's try. Let's see what happens.
Okay, so we can see your Jitsi window with everybody's thing appearing. Can you click on? Oh, there we go. I guess you're. No, that's not it.
Okay, right. So I'm going to stop the sharing. Probably that's what's required for me to go full screen on this. Let's see. Can you see me holding the board now?
Right now, I see a big black screen. Okay, now we see.
All right. So it looks like a big old bone. As
We don't see what you're holding up because that's off the outside of the range of the camera. We see your face and we see your thumb, and there's a tiny little bit of a piece of electronics on the side. And now we see nothing there because you moved it away from the camera completely.
So okay, so you're looking at me on the other. All right.
Yeah, there are two Federico windows.
Right. You have to look at the right Federico for the right thing. So let's see. Can you see the board now?
You can see about half of the board now with your thumb.
All right.
Okay, there we go. That's the whole board.
I should have mounted the microscope camera, but I didn't think it would be needed.
It also keeps switching off and then saying video for fellow Jits has been turned off to save bandwidth. So apparently there's some issue with your bandwidth. So it's like your video keeps cutting in and out.
Okay. Let's change that to not use. Let's see what happens. Is it more reliable now?
Yep, now we see it. It's also reversed, so we see it on the other side. Oh, it just turned off again.
No. Okay.
No, I can see it in his phone window.
All right. Okay, let's try to do it this way then. So, as we were saying, this is a Beagle board. It is in the usual format of every Beagle bone since the first Beagle bone. It has a slightly different layout and a slightly different set of components. It has the usual 46 pin headers on the side, 1 gig of RAM, high-speed USB, micro HDMI on the bottom side here, and there are 5 user-driven LEDs and the reset button. Ethernet is gigabit. Power is USB-C. So pretty good. Now, what else is there? There is obviously a micro SD card, as they always do. And the USB-C is 5 Gbps super speed USB. It's not just power. And it's operating in host mode. Okay. Then last thing, if you look quite close, you can see that there is an antenna there, so that it has built-in Wi-Fi. All right. So that's pretty much what's in the box. There are no additional things like cables or power supplies or anything like that. Basically, it's the board, a little bit of legal documentation, and instructions to get you started, where to go to get bootstrapped. I'm not sure why we wound up on DigiKey on the share here.
Federico, what kind of Wi-Fi does that board have?
Let's find out. I don't think it's what you're hoping for, Kurt. That's my summary view of it. Okay. Google seems to think that this is a 5 gigahertz processor. If it is, that's certainly a good thing. All right, so spec sheet. Dual Cortex A15, 2 floating point DSPs. These are always something interesting that the BeagleBone has and that people underestimate. 2.5 megabytes of on-chip level 3 RAM. 2 dual ARM Cortex M4 co-processors. You can use those to run real-time tasks asynchronously from the OS, I believe. Oh no, these 2x dual core programmable real-time unit, the PRUs. So with those, you can keep much finer timing than the operating system could. There's a 2D graphics accelerator. The GPU is a PowerVR SGX 544. Apparently, it can encode and decode 4K H.264. I'm sorry, 4K H.264 at 15 frames per second. I don't know that that's particularly interesting unless you want to run cameras, but because the applications for this are AI, obviously being able to manipulate video is interesting. Ethernet is gigabit, Wi-Fi is 2.4 and 5 gigahertz. The OS is preloaded and it's Debian, so the board is ready to go. And besides the 1 gig of RAM that I already mentioned, there are 16 gigs of onboard eMMC flash. This is really fast permanent storage. So usually with BeagleBone or BeagleBoard type applications, it makes perfect sense to try to host things in the eMMC or the built-in flash if you at all can, because it's obviously not just much faster than the SD card, but also much more reliable. SD cards tend to fail on you at the worst possible moments. So being able to work without an SD card is a great plus. Okay. Apparently you can use OpenCL on the PowerVR accelerator, and that's where the AI comes from. So you can train models. All right. Let's stop there. I'm sure that if Jason manages to come, he has much more. But this is the latest on the creations from BeagleBoard. I did not order this one, so I don't know how much it is. Let me see. Mauser says $127. Okay, there you have it. Now, another one about same size is the Latte Panda. Now, I know this is sacrilege and blasphemy, but it is still interesting and still worth knowing. Now, why is it sacrilege and blasphemy? It's a Windows 10 board. So Windows developers have been a whole lot out of the game in these IoT edge type applications with low power. This is one chance that they have to get in the game. And there were a few other things. If you remember, Microsoft had made some developer kits a few years ago. I don't know if that went anywhere. They were basically a Windows-based Arduino, if you remember. There is an antenna terminal. This one is provided separately. And the board itself. This is a Chinese project, so they don't have a page of "Don't sue me" boilerplate. They don't have to worry about that. And because this is, I believe, an x86, it is shielded to no end.
Okay, again, we're not seeing whatever you're holding up. We're just seeing the web page.
It's the other Federico.
Right.
Can you see it?
Nope. Still just seeing the web page.
Yeah, it's his other Federico, so I can see it. It's in his other login.
Yeah, but it's not showing up on YouTube.
The other camera is not going to be good enough to show you the board, Jabber. It has to be on the phone camera.
What processor is that, Federico?
So let's go bring this up. So the claim to fame for this one is that is obviously the Windows 10 support. And there is a teeny tiny manual. Let's see if there is a legal disclaimer. Maybe Chinese companies are just as hamstrung as we are. There is a little bit of instructions for safe use in the FCC statement. Not too much. Power up instructions, connecting to Wi-Fi. That's about it. Okay, so the specs for this one are Intel Cherry Trail quad-core. The CPU is a Z8300. It's clocked at 1.8 gigahertz. There are 2 gigs of onboard RAM. Let's see if I can find them. I'm guessing that they're probably shielded underneath here. There are 32 gigabytes of eMMC, so same logic as what I was describing before with the BeagleBone. If you can fit your application in there, do it. With 32 gigs and Windows, it may be a little bit tougher than 16 and Linux, but there you have it. The GPU is an Intel accelerator. RAM is single channel. I don't know if that matters too much in this case. There is an HDMI video output that I don't see. Ah, there we go. It's full size, unlike the BeagleBone that was a mini connector. That's nice. There is a variant with 64 gigs of eMMC, not the one that I have, but there is another variant of this board with 64. Power consumption is 2 amps at 5 volts, so not too bad for a Windows system, I would say. There is an Atmega 32U4, which amazingly must also be shielded. No, I think it's here on the underside. If at least I see the Atmega logo. As an Arduino coprocessor, so you can run Arduino logic on the Windows host natively without doing any translation or anything like that. Let's see what we have on their marketing. Or hopefully their spec page if we're lucky. I think we pretty much covered everything that there is to say there, but it's nice that there are options if you have to have Windows. The problem is that if you have to have Windows, usually you need way more than an edge device. You need a real computer. So in that case, you're much better off looking at industrial PCs, which are fanless and have basically the case is a huge heat sink. The ones that are environmentally hardened are about $1,000. So we're not talking military specifications here or military costs, but obviously it's not the same thing as a $100 board. So let's see. Oh, there is the Arduino pinout, which I didn't point out, and there are a bunch of sensor connectors. I forget what these are called. I think that this is the Seed Studio standard for sensor connectors. I'm drawing a blank on what they're called, but it's a standard white clip so that you can attach to two terminal interfaces, and for the array of sensors that are available from Seed Studio, it should work just fine without you needing to do any soldering or splicing. There is a really tiny touch panel connector that I skipped over when I was going over, and there is similarly a display connector, and you can see them here at the bottom, just like the Raspberry Pi ones. One of the USBs is USB 3, and one of the USBs, the two stack, is USB 2. GPIO headers for the board are brought up with a raised connector here, which is really nice. There is Ethernet. We need to find out what that is, but I'm guessing it's a gigabit Ethernet. We'll find out in a second. There is an audio jack, very nicely. And the power port, which is micro USB. So you can recycle one of your Raspberry Pi power supplies. Raspberry Pi 3 power supplies. They should be good for 2 amps, I think. most of them anyway. Okay, so I already mentioned there is 32 gigs and 64 gigs options. This is a 4-core board, 1.80 gigahertz. So it's basically it's a laptop from 10 years ago. It's a little bit better than a laptop 4 years ago. I'm sorry, 10 years ago, because those would have been probably 2 cores. 4 cores would have been at the high end. But yeah, it's a high-end laptop from 10 years ago. I believe that it comes preloaded with Windows 10. That's certainly how I ordered it, because I have lost my Windows skills after college. I go nuts every time I have to install Windows, so I didn't want to deal with it at all. So the one I ordered is preloaded. I'm not sure. I think that you can order it with Windows and without Windows, and it changes the price a little bit. Anything else here? No, that's it. Prices. Yeah, you see, it's $99 without a Windows activation. For those of you that have a corporate Windows activation server, and you can get your license from the all-you-can-eat Windows. And pre-activated is $129. And then the 64 is a little bit more. All right, next. I'm going to skip to the most interesting thing in case Jason appears and have to hand over the torch to the star speaker of the night. So this arrived Friday. It is a Turing Pi v1.1. What is a Turing Pi? Kurt, do you know what a Turing Pi is?
No. It's Pi, right?
Yes.
Did it
So
come out on
I'm
Alan
glad.
Turing's birthday or something? Or
I'm glad, because I was speaking at the Down Under conference, LCA, virtually in January, about building Raspberry Pi clusters. And someone asked me about, what about the Turing Pi? I was like, the what? And so I learned about this thing that was in Kickstarter at the time.
oh wow!
This is the first release of their Kickstarter. This is like the Pine board cluster. I have a Pine board in the office, but I forgot to bring it. But it's basically the same layout. You can build a cluster putting Raspberry Pi compute modules into this cluster board with all the interfaces on. Now the Pine board is not bad, and it's compatible, I believe, with Raspberry Pi 4. This one was designed from the ground up for Raspberry Pi 4. So you can have nodes with 8 gigs of RAM, the latest Raspberry Pi processor, and you can have, I believe it's 7 nodes. Yes, it's 7. So I would take the first node as a head node or a lead node, and I would make the next 6 secondaries. So I would count it as a 6-node cluster with 1 management node. But depending on how you do it, maybe you can extract useful work out of all of them. There are a ton of USB ports here. There is, I think it's a CR2232, or its cousin, the little lithium battery, so that it doesn't lose time when you pull the plug, which, like Kurt was saying, is the bane of all these boards, because without time you cannot do SSL. And if you cannot do SSL these days, you cannot do the network, because you cannot trust anything, with supply chain compromises being all the rage and all that. Standard barrel connector for power here, but also a power connector of the type that we like for CPU power supplies. A number of jumpers that I don't know what they do. And there are interfaces that are brought out of the first node, audio and HDMI. And interesting detail, because if you haven't used a Raspberry Pi node, a Raspberry Pi compute node yet, you know that it doesn't have onboard storage, so you have to somehow bring the DOS. You have all of these SD card slots, so you can load DOS images, one per node. Okay, so that was a nice surprise, and it was being the money was being collected in January, so I guess I wasn't too remiss in not knowing about it. And this was delivered last week. They just finished. This is a minor revision. They call it 1.1. I'm not sure what changed. Let's see if I left anything out in the specs.
That's a really nice design. I know Seed Studios has a product that you can put 4 Jetsons into. I think you have to take them off of your Jetson dev board and then stick them in line. It looks a little bit like that, except that it's basically 2 U's between slots. I think it's called the Jetson Mate. So I haven't gotten one yet, but I'm going to check that out. That's going to be much more power hungry than what you just described.
Yes.
Yeah.
I've seen a few things with stacks of Jetsons done, and I can't justify buying a pile of Jetsons, so I haven't done it. But it seems to be the trend. And there is also one thing that's going on, which is people are making rack mount solution for Raspberry Pis and Jetsons. There is who is it? I think it's Pi Moroni, or one of the vendors on the Raspberry Pi ecosystem. They make these blades that you put on the front of a computer rack, and you can mount really many Raspberry Pis in this. I think it's a 2U space. The space behind it is completely empty. It's just the front that has the boards. Usually, the problem with building clusters out of Pis or any of these edge things is power distribution and network distribution. So the thing that's really cool about this is that this is going through the backplane. Unlike the clusters that I've shown you last year, where there is all Ethernet wiring bouncing all over the place, and we try to be clever about the power, but there is also power. Just we're using one power supply distributing to all nodes, but we still have wiring. This is basically letting the backplane take care of that. So it's really, really clear. Sorry, it's really clean. The backplane board is 199. Probably hosting Kubernetes clusters for demos is going to be the primary use that a lot of people are going to do with it. I'm interested in building a Ceph cluster here, but the problem is you can produce only a minute amount of storage this way. So compute seems to make more sense. And then the HPC demos that I like to do, where I show students how to program MPI using Raspberry Pi. And this is basically the next generation of that, because with 8 gigabyte Pi 4s, we can actually, I'll have to rewrite the code because it's going to overflow in the current 32-bit data types. I need I need the 64-bit Raspbian, and I need to rewrite parts of the code so that the Monte Carlo counters don't overflow. And by don't overflow, I don't mean they don't overflow in a week. They don't overflow in a minute. And that's where we are at right now. If your Monte Carlo simulation is well optimized, my Pi counters would exceed 4 billion in less than 60 seconds. So I couldn't do the MPI gather properly. I would get garbage. So let's see if I left anything. There is GPIO. I presume it's the GPIO of the first board. Up to 28 cores. Let's see, 4 times 7. That makes sense. As a cluster management through I2C, I wonder how that is done. Nodes power management on the board, as I was saying. And you can flash them and boot them. The fact that the clock is on board is not something to be underestimated, because it means that you can bootstrap from the network safely. So you don't have to have anything locally. You could just pixie the whole board, because you can initiate a proper SSL download without risking any sort of download attacks or supply chain attacks, as they call them now. Some configuration with dip switches and an I2C port, and that seems to be it. Well, from where does the OS boot? You can boot from eMMC, SD card, or netboot. Well, nothing too strange there. I wonder if the board itself has an IP address. That's what I'm curious about. It can be driven with a 12 volt power supply or an ATX. Somebody's mounting them in computer chassis. That's kind of cool. Huh. All right. So that's the best thing I have here. Let me see. Oh, one more detail. If you can see here on the diagram, the GPIO for each module is being brought out. So I'm not sure what application would use that, but if you're wiring sensors to each node, you have the full GPIO brought out next to each one. And you can see it here. There is the standard connector next to each module slot. So it's nothing unusual. It's the usual standard. Okay, let's see what else. This one, I'm going to give it honorable mention just because I know several people that work at this company, and they seem to have lots of fun making hardware. So this is a Balena fin. So I don't know what Balena does anymore. They were one startup that was doing edge stuff, but they are one of these companies that seem to have a lot of fun doing good jobs with the tools that they're building. So, for example, they needed to build to burn lots of SD cards. So first they published their software for burning SD cards, which works on Linux and works on Linux, and it's great because if you're, I'm sorry, it works on Windows, Linux, and Mac OS. And if you ever try to burn an SD card from Mac OS, you know it can be painful. So you have the entire tool chain and set of errors worked out for you, and it's basically one download, one click. And since they had already made it internally, they decided to release it, and they're maintaining it very nicely. So now every time I burn a card for a Raspberry Pi, and I have to do it from the Mac because I don't have a Linux host handy, I just go there. It saves me significant time trying to figure out how to get to the raw device in the Mac. They did another thing going further there, which is that they built this machine that is being sold for several $1,000s, where you have an incredible number of USB ports. Can't remember if it's 32 or 64. And basically, it's used to load the contents of a ridiculous number of USB keys all at once and really fast. And I suppose that could have edge applications, but it could also have marketing applications when you're giving your collateral to people at the booth. And sometimes you see people making copies of things onto files one by one, and it's a pain. It's a waste of time. Here they do it 64 at a time. And obviously, they were having lots of fun building tools like that. So that's the next one that they've released. So the Balena fin is an embedded board, just like the ones that we have discussed so far. It has a slightly different aspect ratio. As you can see here in the camera, it's square. It is a Raspberry Pi compute module host board. Here is the module on the back. This one came with a compute module 3. I do not know if it's compatible with Compute Module 4. We'll find out. It has a battery connector for maintaining the RTC clock, as we were saying earlier. And it has a color-coded GPIO connector, bringing out the connections from the Raspberry Pi. It has a few other things, HDMI and the camera connectors. You can see them down there, the ribbon connectors. And I see an HDMI built in. I see a micro SD card. And let's see what we get in terms of specs. Okay. I like the fact that the Balena teams seems to be focused on making things easy and reliable and durable, I guess is the right word here. So I don't have firsthand experience of how rugged this is, but I'm pretty sure that it will evolve over time as they find out what people stumble on and what they found difficulty with. I believe the one I have is a 1.0. Let me see. Yes, V1 1.0. Here on the website, it says there is a 1.1. Oh, here we go. The connector that I was not mentioning here is how you flash it with over USB. There are USB headers brought out so that you can bring in connectors that you attach to an external chassis. Let's see. Oh, it has built-in power over Ethernet, which is pretty commonplace for Raspberry Pi these days, but you need to have an additional module to do this. This is built in. Improved operating temperature range. I'm not sure what the concern there was, but it goes to my point that they always refine their work. And apparently it can support 2 cameras instead of 1. I guess the ribbon connector must be enabling that. So nothing too interesting per se, but there aren't a lot of boards that let you host a compute modules. A Pi compute module. So if you just need one compute module instead of a fleet of them, as I was showing on the Turing Pi, then it might as well be this one. It's very recent, comes from a team that has a lot of detail for attention, and yeah, that's basically the way I think of it. There is an antenna switch, so you can physically turn off the Wi-Fi. There must be a port to attach the antenna, but I can't see where it is here. I apologize if you can hear that, but my daughter's dinner time shall not be interrupted. So what else is here? Ethernet, USB, we covered pretty much everything. So there is a physical switch for the Wi-Fi, which is something rather unique. I suppose for other boards, you could yank the antenna and count on proximity or wrap it in aluminum, but a physical switch is nice. There are a bunch of LEDs built in, user controllable, so blink and lights. And it looks like there is a physical switch for the camera as well, which makes perfect sense. So that's it for this one. And then we're going to go to the last one. So you need to find JSON because I'm out of material. This one is an Azure Sphere development kit. Now, these are made by Microsoft with Seed Studio providing the hardware and the integration services. It's an interesting board. It has dual band Wi-Fi and all of the usual things for IoT devices, but that's not what makes it interesting. What makes it interesting is that Microsoft is trying to solve the secure software supply chain at the edge problem, and they're basically giving you with the board a unique certificate that's meant only for you. So when you activate this board, you can activate it only once. It attaches to the Microsoft service, and you control that password so that end to end, the firmware chain can be secured in all the various ways that we know. Downloads are secured, the downloads are signed, and so on. There are startups that do this for Linux, to be sure, but Microsoft, as usual, is trying to make things easy. So you basically have an integrated end-to-end tool chain to do it. I haven't managed to find an application for it yet because I don't work with Windows, but I like the security aspect of this, and I have a friend at Microsoft that who swears by it. So he gave me this and asked me to play with it right before the pandemic, and I haven't had time to do it yet. Aside from the supply chain integration, the other thing that is cool of this board is that you could work on this with Visual Studio before Visual Studio for Linux came out, right? So you got on the most usable developer tools possible. I don't think that 3620. I don't think that the hardware is all that remarkable. Really, the firmware supply chain aspect is what matters here. But let me see. There are too many. Get started. Oh, there we go. Seed will have the specs. Okay. What's going on with Seed Studio? All right, it's slowly arriving. So, it's sold out apparently right now. It's $93. Specs. Whoa, sorry, I inadvertently back scrolled. Let's see. Okay, where are the specs? I don't want a video. I want the specs. This is unusual. There's too much stuff, and therefore you cannot find the right one. Oh, there we go. Right, so one Cortex A7 at 500 megahertz, 4 megs of RAM, two Cortex M4, 200 megahertz, 64K of RAM. So this is basically a Windows Duino, if you want to think about it. It's a bare metal device where you're loading your programs in there. Probably Visual Studio is going to give you libraries to make things more friendly, but you're not writing on top of the OS. You're writing on top of some library that's bare metal. 802.11b Wi-Fi. There is a real-time clock. So let me see. We had one real-time clock, 2, 3, 4. I don't know if the BeagleBone AI had an RTC. Let me check. Maybe not. So if this one doesn't have it, it's 4 out of 5. I have the RTC. I guess everybody has woken up to the fact that you do need an onboard clock. Yeah, the Beagle doesn't seem to have it. So clocks are prevalent now. 4 out of 5 are battery-backed clocks. in place. So new generation of edge hardware. I don't think that there is a whole lot more to say about the Windows thing. The USB port is the power. It's also the debugging port going to Visual Studio. You're going to run Visual Studio on top of Windows 10, program it in C, and that's going to be it. And then you have to work through the tutorials from Microsoft to see what the environment looks like. But this is interesting because this is a secure supply chain solution, and this one I got in the spring of 2020, but and it's the newest one. I had a pre-release version that was from the spring of 2019, or first release version. So it's been around for a while. It's not. It may not be fair to compare it with the latest things. There are battery connectors, and I'm trying to magnify here where they are. You have the full range of Arduino pinouts. And looks like there is a reset and 2 user buttons labeled A and B. Some some user LEDs, 4, and Wi-Fi power, network, and I'm not sure what the triangle is. That's the antenna connector, the 2 antenna connectors for the Wi-Fi, 1 for each antenna frequency. And there is a built-in antenna that you can see there. It's a board surface. It's a surface mount antenna. Okay, that's it. That's what we have in the lab right now. Any questions on these?
So I'm not totally convinced that you need a real-time clock. You know, I understand in the early days the reason they had to ship these boards from China is, you know, no lithium batteries. It's like, okay, so let's just ship a board that doesn't even try, you know, doesn't even have a socket for a button cell like the ones you have. I mean, that's much more fashionable now. Maybe you just ship it without a battery. I don't know, but you know, it's, you know, TCP is stateless, so you've got quite a lot of room for jitter there. You can write WTemp every day, you know, just before shutdown or something, you know, and you boot up and it comes up as January 1st, 2002, or something crazy like that, and you can still do SSH, right? You know, it's like, don't you have like a lot of leeway there before you have to, you know, actually get within a couple of minutes of the real-time clock?
I think you do, but the problem is the industrial aspect. So, you know, it's something that we always run into at Red Hat. Like, I get asked, can't you support protocol so and so with Ceph? There is a module, and it kind of looks okay. Well, maybe it's tagged experimental upstream. Never mind, but it's maybe cool. Can't you guys support it? And yes, we can support the experimental code from upstream and try to get you out of that train wreck, but it's very expensive and it's very time intensive. Basically, we have to dedicate somebody to get this person out of the mire when they get into trouble. It's not economical for us, and it's not fun for the customer who expects to be back to the same level of quality across the entire product. When you're looking at industrial automation, which is basically what IoT is an offshoot of, if you're looking at IoT as your hobby, you can basically survive anything because you can tailor the solution to the problem in question. You will invent a fix. But industrially, you want to have things that ideally are never broken. If they break, like you were saying about the nodes on the roof net, you replace them. You don't even bother fixing them. And you have to have absolute certainty that they're secure, because you're not going to have a red team do penetration testing or anybody trying to fix the security after they've been breached. So it may sound a little bit overkill to say you're going to have secure supply chain to an Arduino that's atop a telephone pole, but it makes sense economically in light of you're never going to touch this again, and you hope that your security is good enough. But if it's not, you're going to throw those away and replace them with a new version. You're probably not going to fix them. So in light of that, I think the clock makes sense. By the way, one thing about the batteries. I was looking into the IATA regulations for shipping batteries. The regulations are that you can ship a 20-gram battery just fine. And you can carry on an airplane something like 20 or 40 of those batteries in your carry-on luggage, and that's permitted. The problem is not the regulation. The regulation is reasonable. I think the reason for that is that people use it for their hearing aid. The problem is that when you make complex regulations, people don't know what the regulation is. So are you going to argue with the gate agent, yes, I have 20 batteries, but they are allowed, when 90% of gate agents have no idea about that? I had this experience a few months ago from Australia. They wanted to mail me the badge for the conference that I spoke virtually at. And they're like, well, there is a battery here. I was like, it's a CR3220. It's fine to mail it. It's like, well, yes, but the post office does not understand the shipping regulations as well as you do. So you run into all sort of bureaucratic obstacles more than real rule making or real technical stuff. So definitely ship without battery. That would be my advice.
Oh yeah.
Okay, let's see what else is going on here. I'm curious about the Latte Panda because I'm not quite sure what you do with Windows 10 at the edge. The Azure Sphere is basically an Arduino at the edge. It's made very Windows friendly. I can understand that part. The Latte Panda with running Windows at the edge, I'm like, I need to figure out what I would use that for. Maybe drive a TV screen. I'm not sure.
Yeah. Yeah. Well, I have to look into, like I say, for some reason, I've been watching a lot of news reports on this. GPUs are very hard to get these days, discrete GPUs, the high-end NVIDIA cards, the high-end AMD cards. So we may have to reinvestigate doing a Jetson cluster for the student cluster contest. And so the student cluster contest is something of a synthetic contest because we have a 3,000 watt cap, which isn't real world, for if someone says go out and build a cluster that will hit a certain, flops number on a benchmark, they wouldn't say, oh, and cap it at 3,000 watts. That wouldn't be the arbitrary, variable that they would decide to restrict. It would be something else like cost or generation or something. But so we said, okay, well, how many GPU flops can we get at 3,000 watts if we built it out of dev boards, right? And that's could be a crazy amount of flops, but we would also have to consider all of the Ethernet concerns. But this might be the year to consider that because we can't get discrete GPUs.
You can't get the GPUs.
Yeah, so maybe we'll do that this year.
I was at Micro Center yesterday for the first time in a long time, and I noticed that all the GPUs are now behind glass.
Oh, really?
They're very fancy wooden cabinets for the GPU.
Yeah. Well, I understand if you just want gamer cards, all of the Chinese Bitcoin miners are dumping them into the eBay right now. So you can get a GFX Radeon type stuff really cheap now, but you can't get the high end stuff.
Yeah, if you hit the right timing, you can do a pretty interesting stuff. Like I think it was April or June. Maybe it was June last year. There were a lot of people offloading their Knight's Bridge accelerator.
Oh yeah, Knight's Landing.
Right, you could get a night's landing for $100 or something crazy like that.
Oh wow.
Potentially, you could build a cluster of night's landings and have you can definitely build a cluster with 240 Intel CPU cores. I wonder
Yeah,
if
for
you can
sure.
build one that goes to 512. I'm not so sure. The problem is the BIOS support for how many boards basically can you load, and Night's Landing was not super popular, so there are only some boards that will take Night's Landing. So you have to find the right Dell or HP server.
Yep.
What specific card are you looking for, Kurt? And how many
say-
do you need?
You mean for Knight's Landing or for
No,
uh,
for the competition,
uh
for participants.
we're looking, well, ideally we're looking for A100s. I think we could probably talk to a bunch of friends and family and get some V100s. Like I say, for if your cap is 3,000 watts, that doesn't describe too many systems with GPUs in it. It's probably 2 servers with V100s, 8 V100s each, maybe. But ideally we would like to borrow, like I say, borrow, beg, or steal A100s because that's the contemporary generation, right, for the NVIDIA GPUs.
I see.
Right. So I don't. How many amps are we talking about?
So you could get a 300 watt A100 video card, which, like I say, if you're putting 1 or 2 servers together, you run out of 3,000 watts really quick if you're running a 300 watt video card. And I know systems that have 8 A100s in them, and they're running flat out. They're overclocked, 300 watts. Some of these servers support 4 power supplies, so getting to 3,000 watts is pretty easy to do if you're doing something like that, overclocking. And I shouldn't use the term overclocking. This is all within NVIDIA specs, but some servers allow that sort of PCI Express oversaturation.
I see.
You don't do anything with GPUs at your work, Federico, or you're strictly a CPU guy?
Yeah, much. We do GPU stuff at my wife's company, but at Red Hat, it's all CPU related stuff. We cannot accelerate Ceph with GPUs. We are mostly looking at special execution instructions for encryption and CRC out of modern CPU cores. That would be an acceleration that would be to us. Compression acceleration could be another thing, but these are all done in you don't need for that. So until we have AI-like extensions for storage, I don't see that.
Aren't those usually done as CPU extensions, though? Your encoding and your CRC.
Yeah, they're done as CPU extensions, but since
Yeah.
we specify what hardware the customer has to buy, basically the customer tells us, I like Supermicro, and so we tell them buy these systems for Supermicro for your use case, or they tell us,
Oh, I see.
so we like Dell, so we point them to the right thing. It doesn't have to work everywhere. It has to work on the vendor hardware for the vendor that the customer chooses, but we pick the chassis and the CPU. So we can basically mandate a Xeon scalable processor, and we have all the extensions we can possibly want.
All right. You had mentioned a board that was the end-to-end secure embedded board for IoT. Is there a Linux comparable setup that you're aware of?
I've seen a couple of solutions for that over the years, and I may have saved them, but not recently. Let me see if I can find it. And there are a few vendors that would do end-to-end supply chain on Linux, and it's basically all software. I think that Balena is one of them, the makers of that board that I was describing before. There is an upstream project that does that, and I'm trying to find it here, but I have too many bookmarks and I cannot find it. Let me see.
I was also wondering if you knew of any vendors. You probably don't know, but are there any vendors that you've heard of that guarantee and will actually, financially guarantee that their wafers, at the silicon level are exactly as spec? So the complete supply chain?
I imagine that there must be something like that, but I haven't had the pleasure. So there was a calculation that Bloomberg published last year that there were hardware supply chain attacks against, I think, super microservers, and nothing really came out of it. The government didn't back that up. The Bloomberg article was not retracted, but nobody was willing to stand behind it. So it was mostly disappointing reporting from Bloomberg. So it was either one of these things that are so embarrassing that they cannot admit that this happened, or it really did not happen. And I tend to lean on the did not happen because there were too many different players, and one of them would have told us. So on the supply chain attacks,
What do you mean, Eric, that they've never found an example? There've been numerous examples of supply chain issues.
yeah,
You mean that one specific
that
example?
one.
I see.
Yeah.
Yeah, sorry, that one.
I think a supply chain issue is something that government to government still. I don't think we're at the point where you have to worry about your motherboards having implants at the corporate level. And that's not because it wouldn't be doable. It's because your corporate security is a mess anyway. So there are much bigger ways to do it than compromising your hardware. I think if you are a government contractor, military projects, sure, you have to worry about that. But just in terms of industrial espionage, if somebody is going to create a hardware implant on your server to steal your recipe for paint, seems like a stretch. Not because they are not trying to steal your recipe for paint, they are, but because they have easier ways to do it, given that you have the IT security of a paint company. So it's a little bit of the threat has to be commensurate to the attack, and you need to fix the bigger holes first, basically.
Sure. Well, for us to move to ubiquitous computing, I think that is something that needs to start being guaranteed.
Yeah, I agree. And I guess the point of the Azure Sphere thing from Microsoft is basically they are guaranteed everything from the board all the way to your Visual Studio endpoint. And
but that's software. That's software only. And if you're supplying the hardware, that's why I was asking.
They are supplying the hardware.
But did they guarantee the hardware?
I don't know if they did or not.
Right. Anyway, I was just curious. Not that there's a business concern per se, society-wise right now, but it is a critical step necessary for the next type of architecture, right? To have proper, ubiquitous computing, to have healthcare. You mentioned industrial, but I mean, this is also important for healthcare, for education, etc. Yeah.
Yeah, at this point, we're at the juncture where basically the denial of service attack is the biggest problem, right? They're going to bring down random services that you don't think of as targets. So what if they bring down, I don't know, the school login system? maybe that's not going to kill anybody, but it's going to cause quite a little bit of chaos if you do it to enough schools. There was this thing last week with contractors, and because it's a federal contractor, the software is used by federal contractors. It's affecting a lot of business. Maybe, hopefully, nobody is dying, but it's still a huge disruption. So the more computing gets everywhere, and now I guess we're going from the desktop and mobile to mist computing, the more you have to be able to secure end to end. And so I think the move by Microsoft to say, you purchase the board from us, we're going to give you the firmware the firmware channel to do everything, and you figure out the software, is the right thing. As I said, Balena has software solution for that, and they will also sell you their own board. I don't know if they guarantee the board or not. And there are a couple of upstream projects that do that. There is one more resource that is interesting, which is there is an article that Adafruit, the two Adafruit founders, Phil and Limor, or Limor and Phil, published on 2600, I think it was last year. It's a very short article. It's literally 4 half-size pages, but it basically gives you the details of how to do a secure software supply chain at the edge from scratch on a Raspberry Pi or equivalent board. So that's a great resource, and they are basically just starting with Linux. You have Linux at one, Linux at the other end. And,
Yeah, I'd love to read that. If you could forward that, I think there are probably a bunch of people who would be interested to read that. But you can have a secure supply chain, right? Because that's a Broadcom chip.
yeah, if the question is the hardware,
So that's
again,
not actually possible. Yeah.
Someone has to guarantee you the hardware for that.
Anyway, it's interesting. I'm in the middle of writing a chapter for that. Anyway, thank you.
Yep. One thing that we have mentioned is there are a few attestation things. They're slowly moving around, both in the cloud and in edge devices. So those may help eventually. I don't see a situation where you can run a trusted code and untrusted hardware at the edge yet, but it seems like you could be able to do that in the cloud reasonably well on AWS, or I've looked at it on AWS and the IBM cloud. I don't know where Azure is. But,
yeah, there are a lot of proposals, but so my question was for an individual, but I'll
yeah.
There are also, from what I'm reading, or from what I've read, there's some interesting proposed methods of like using various forms of blockchain technology to at aggregate remove nodes that are believed to be compromised and stuff, but without a guarantee from like an individual node's perspective, right? You can't secure it without some form of guarantee at the silicon level.
Yes, right. There was a demo a few months ago. There is this project called Keyline that basically manages the health of nodes in the network, again, for edge applications. And this is heavily Red Hat influenced, I believe. So one of our engineers was recording video demos of this, and you can find it on the Keyline website. But it basically shows that you have the node pass a certain number of checks to be able to join the network, and if it fails, any of those obviously removed from the network. And I haven't audited the entire thing, but in broad strokes, it seemed to cover everything needed for a network where the edge nodes were joining and leaving, which is a new dimension over what we were discussing before.
Interesting. Thank you.
Mm-hmm. I'm trying to see if I have the reference to the article by Limor and They write a month for 2600 that's called Citizen Engineer. Well, it was one of the issues of Citizen Engineer. I can't remember which one.
So Federico, I have a question for you. Since this has devolved into an Ask the Expert session, I think.
Well, you
Yeah.
guys are hitting the edge of what I can answer.
Well, I don't think Jason's going to join us. I sent him an email, but I think we somehow missed the connection tonight. So, so my question is this: I don't know if this is actually in your bailiwick, but I have access to a Dell PowerEdge 7525, and it has a ton of NVMe drives in it. So we've been experimenting with different RAID arrays, putting, so it's got 24 slots. So sometimes we do 3 rows of 8. So those are all at RAID 1, and we do them 3 of them at 0, or vice versa, so RAID 50, RAID 51. We're trying to find out the best way. Our goal is to get the maximum throughput with a little bit of reliability. Now, should we introduce Ceph into this at all? Or I mean, is Ceph the wrong direction or the right direction? Our priority is striping. Mirroring is very much a secondary interest to us. Maybe we could get away with just having a parity drive or something.
But you have one server, or how many servers do you have?
Oh, just the one, yeah.
Right. So yeah, it's not the same thing. Ceph is across, right?
Oh, really? So we need the network card introduced in there?
Yes.
I mean, okay.
Yeah, basically the smallest configuration that you can build a Ceph cluster with is 3 nodes. And the recommended thing from us would be 5 nodes.
Oh, really?
And basically, the way we replicate the data is that we don't use RAID at all. In fact, we usually poke fun at NetApp about RAID because we really hate RAID because at the scale of storage that we operate, it's so much storage that if a RAID replication starts with off-the-shelf hardware, which is what we use, your network is hosed. So you can't do that with RAID. So you have to have a system like Ceph where you have as many nodes as you want. Let's say that you start with 3, but our customers have hundreds. And you build in scale-out fashion storage until you get to the number of petabytes that you are looking for. And typically, my advice is if you're not looking at half a petabyte, don't look at Ceph, or at least don't talk to me. I don't want to solve the problem at a smaller scale. The way the replication works is that there is no RAID. We still use the RAID controllers because we like the fact that they're battery cached. So if a node loses power, the last write goes in. We're fine with crash consistency, but we don't like corruption on the last write. So we like the fact that the RAID controllers are battery backed. But other than that, we don't use any RAID whatsoever. We don't do RAID 0 or RAID 1, say for very rare exceptions where maybe we want to make the drives appear bigger. So we use RAID to combine 2 drives into a virtual single drive. And then the way it works is that the individual drives are free to fail. But Ceph is orchestrating keeping 3 copies of the data around the cluster. And so when a drive, a node, a rack goes offline, the cluster starts healing and reconstructing the missing copies so that you went from 3 copies of your data to 2 copies, and you have to return to 3 copies so that you have the HA+1 resiliency level, which we like to operate at. So it's really, really hard to lose data, but obviously we are also keeping 3 copies of your data. In Replica 3, we're literally keeping 3 copies. In other modes, we use compression to lighten the load a little, or in object store mode, we like erasure coding for similar reasons. So because we're already using plenty of space doing this, we are not using RAID because RAID would double our use of space at least, and it wouldn't make sense. Besides all the performance issues that I was saying. So yeah, On a single node, I think that you can basically optimize your RAID configuration. You can figure out what's the best file system for you, and then and that's what you have. Because you have all solid state, your first bottleneck will be the CPU. Solid state is going to eat CPU like crazy if you're trying to max out the storage. So make sure that you have lots of CPU cores to use.
So I've also heard from the drive manufacturers that we want to keep the drives at less than 25% so that we don't hammer the flash. They said, look, as long as you keep these, especially since we're doing striping and we don't care about, if I've got 6 3.2 terabyte drives and I only get 3.2 terabytes out of it, that's fine for us. They said keep them at 25% and you won't hammer the flash.
Hammering writes or hammer in which sense?
Writes. So I said we want to access this stuff at the fastest rate we can. So the PCI bus is capable of 64 gigabytes per second. We want to access it at that rate. So that's why we're doing these RAID stripes. And they said, okay, well, just keep the drive no more than 25% capacity, which, like I say, that the math is there for us because we don't care about mirroring. We might care about like one parity drive. I mean, I don't want to throw the whole thing away if we lose it. Like all 24 drives on striping.
Happen in the middle of your demo, you know that.
Yeah, exactly. So, but we're going to experiment with that and see if that works locally. Maybe it'll work remotely too. I don't know. The Mellanox guys say you only pay a 1 millisecond latency hit when you go across the network, and that's not bad. I mean, we're doing 600 nanosecond latency hits, locally. So what's another 300 nanoseconds? And
yeah, but the one thing is what you're doing with the hardware. Then there may be more. If you don't have to cross the network, don't cross the network.
Yeah. Yep. This is part of the same project. We're trying to keep stuff under 3,000 watts. So if we can do that on a single server, we will. If we have to, for performance issues, go off server, then that introduces network issues. So we'll sort it out.
Understood. I don't know why you would need to keep the flash at 25% because unless your workload is super write heavy, that shouldn't really be a concern. But regardless of what you're doing, solid state can basically go as far as you can take it with the CPU that you have. So that's most likely going to be your bottleneck. The other
really? Okay.
Is that you're going to run out of PCI. If you have a recent AMD system with like a ROM or anything like that with infinite number of PCI lanes, maybe you don't care. For older systems, you may have PCI problems. In my experience, however, you always hit the CPU bottleneck first because the NVMe is so fast these days that basically you keep asking for data and you keep getting it, and it's it's unbound. So you can eat as much CPU as you have and no more.
Yeah. Okay. Well, we're running some tests. This is a really good system we've got. We're going to hammer on it for a while, and I'll give you some feedback.
That should be interesting.
All right. Well, it looks like Jason's not going to join us. I don't see him, so not sure what happened there. That's too bad.
Well, I suppose it's our opportunity to organize a talk by him alone next time.
Exactly. Yeah, he owes us. Jabber, what I can do is I can fix up my slides and do a voiceover, and maybe we can fix this in post and glue it to the beginning of this video or something.
I'm not really that sure about editing it in the video like that. That's a lot more editing than I normally do on them.
Okay.
We can post it as a second video, I guess, if you want to do that.
All right. Yeah. If you edit this down and just concatenate it, sure.
Yeah, I guess you can cut out our IT issues and our various setup for starts.
That's true.
That
We
should
could
keep
call-
reasonable in size.
Yep. We could have the Federico unboxing and then I'll edit down my video. What I can do is I can talk over my slides and I'll just give it to you, Jabber.
Well, actually, we can't do anything about Federico unboxing because none of his unboxing appeared on YouTube at all.
Oh no.
We'll have been talking about unboxing, but it's showing what was in his web browser the whole time. There's no video of doing the unboxing.
We had the audio of the unboxing.
Right, so we can hear the crinkling of the plastic.
The tiny printing of the plastic.
All
I
right.
think you should leave it as is. Just cut out the IT loops. The part of Kirk's talk that I've seen was good. I don't see any reason to redo it or re-edit it.
Yeah, you can just send me your slides because I normally post slides along with the video.
Oh yeah, okay. So the good news is Cambridge Brewing Company is reopened. So maybe we'll even if we can't get into an office at MIT, we can meet over there and get some pizza or some garlic or something and one of these days.
So basically, you're saying that we're not going to be able to meet at MIT in September. What about January 2022 or January 2023?
Okay, so January, that's much more encouraging. What we've heard about September is very, very much negative, insofar as they've given us any guidance at all. But yeah, give it another semester. Maybe January, we're in better shape.
By the way, I'm happy to do editing if you send me something, Kurt.
Okay, good. What do you have for a system? You've got an Apple that you work on or something?
Linux. You can use Kden Live.
Oh, okay.
Yeah.
Yeah, sure.
Yeah, so MIT, is that are they going the way of Papers, Please?
So insofar as we've got any guidance at all, and I can understand their reticence to telling us any information. They said September 1, the students will be back in what's effectively normal mode with once you've convinced the administration that you're vaccinated, you can walk around campus without masks. Now, that doesn't really give us much information. It doesn't tell us whether we can reserve rooms or anything like that. That's just kind of a student guideline that they've published, but hopefully shortly thereafter. And if, ideally, I know John's worried about things like, where can we get access to space for things like meeting on Saturdays and things like that. I mean, our Wednesday night meetings were a little bit easier to schedule than our Saturday morning meetings. So I understand the concerns there. We'll probably get more information on that after September. I don't know if your school is. What's your school looking at, Josh? Are they doing?
They are trying to. Rhode Island wants to do Papers, Please as much as possible.
Okay.
Is the general vibe.
Yep.
Don't move to Rhode Island. There's a lot of engineers, I think, that are going to be moving out.
Oh, man. Okay. Yep. Josh, what does Bark look like for January? You think it might happen?
I asked the building manager, and they told me they have still not finished the building that they started planning a decade ago, and we moved into 2019, I think. Took them 4 years to build it before that.
Yeah. So it might be virtual again.
Yeah, and you might not want to do it in person anyway. You or I, my gut feeling from and from asking people is that they'd probably try to, break HIPAA and try to find out about every participant.
Yeah.
It's unfortunate.
Yeah. Okay. All right, Jabber. Thank you.
Oh, sure. So I guess we're pretty much done here.
Well, I guess we need to figure out if the barbecue is on next month or not.
Oh yeah, it's definitely on. We're scheduled for August 15th.
Understood.
I think I have that on the website already. Let's take a quick look here.
Are you going to bring your Tesla, Jerry, to the barbecue?
Oh, it's August 14th, not the 15th. Jerry, I think you're muted. I don't hear you.
I've actually tracked out a bus route to get to their house, so I'll hit that this year.
I think Jerry's trying to talk, but we're not hearing him. Still not getting any audio.
So we can't hear you. It looks like you're talking though.
I should probably stop the live stream now. Oops. I forget where to do that.